Hi, my dear students. In this session, I'll explain about complex numbers. The complex number is represented by C. I is equal to square root of minus 1. For example, let me consider square root of 4. That gives plus or minus 2. But what about square root of minus 4? You cannot say either plus 2 or minus 2, but instead you can split like this, that is 4 into minus 1. So you can put root of 4 into root of minus 1. Therefore root of 4 is plus or minus 2, and the square root of minus 1, that is given as I, that is imaginary number. Okay, so I is equal to square root of minus 1. It is generally represented by Z, and that is expressed as x plus iy, where x is the real part of Z, the complex number, and y is associated with the imaginary number, and that's why it's called imaginary part of Z, that is the complex number. And you should understand, for example, when y is equal to 0, you have got only a real part, is it not? So x only, that is nothing but a real number, and when x is equal to 0, you have got the imaginary part, and that itself is a complex number. So it is generally inclusive of real number also. A real number also can be represented as complex number. So in that case, it is the subset of what? That is, real number is a subset of complex number. Now let us discuss about the conjugate of C. So the conjugate of complex number, they are, for example, when I say x plus iy is a complex number, what is the conjugate? You have to say change the sign. X minus iy is the conjugate of complex number. And when you represent x plus iy by z, then its conjugate is represented as z bar, that is x minus iy. So that is what I have given here. Now let us look at the representation of a geometrical representation of complex number. Xox is the x-axis, y dash, this is x dash, y dash, the vertical axis, that is the y-axis. And now let me represent a complex number by a point P of x comma y. So in that case, this is the complex number, that is P of z or P of x comma y, that is a complex number. That is represented as a point in xy plane. Okay, for example, the xy plane, here it takes only the real part, whereas y takes the imaginary part, and that is why it is called the complex plane. And it can also be called Argand plane, and that is also known as Gaussian plane. Now, when I put x and y 0, then it is the real part of a complex number. So that axis can be represented as real axis. And similarly, y axis. So here, when the real part is 0, and if you have got y, it will lead to iy. Definitely, it is the imaginary axis. So this y axis is called the imaginary axis. Now, let me consider this is x, okay, and this is y, right? So if it is y, means this is also y. So we can apply Pythagoras Theorem also, being a right triangle. So in that case, x squared plus y squared is equal to the hypotenuse squared, which is nothing but OP. So this OP is nothing but z, okay. So z is equal to the whole square root of x squared plus y squared. Are you able to follow? So here z is equal to OP, that is nothing but the whole square root of x squared plus y squared, and z bar, that is given as OP dash, that is the conjugate part of the complex number can be represented as P of z bar, which is just opposite to that P of z, okay? And it is given as what? Z bar, which is nothing but OP dash. So when you have got the same result being the modulus, therefore z bar modulus of z bar is equal to modulus of z, because OP dash is equal to OP. So these are the basic ideas about the complex number you should remember. So in the next class we will be discussing about the basic properties of complex number, and followed by that we'll try to solve some problems. Okay, thank you very much for watching this video.